All right, we are on to Unit 3. Goal for today, what our main goal for today is to really start to understand what the word transformation means, what different transformations are. We're going to first identify what a rigid motion is. We're going to define that and chat about that. And then the second thing is we are going to discuss one of the rigid motions today. We are going to be doing reflections. So by the time you leave me today, you will be able to know whether something is a rigid motion or not. And then you are also going to be able to do reflections. So let's define rigid motions. So a rigid motion is any transformation that maintains side lengths and angle measures. So basically what that means in Condell terms is that you have two congruent figures. Now these figures or these two shapes may be flip-flopped around or whatever, but the side lengths would remain the same and the angle measures in the corners would remain the same as well. So basically you have a rigid motion from one figure to the next if they look exactly the same, but again, maybe they're flipped around. So we are going to be chatting about a couple of different transformations that are rigid motions in this unit. The first one that we are going to be chatting about is reflections, are reflections. So we're going to be doing reflections. And then the next day that we meet, we are going to be talking about translations. And then the last one is going to be rotations. So today we are going to be talking about reflections, though, once we get into our transformations. But first, we're going to take a look at a couple of examples and kind of help you to see really what is or is not a rigid motion. So if you take a look at these two figures or these two pictures right here, this is the pre-image. This is where you start, and then you apply some type of a transformation or apply some type of well, this would be a transformation of a dilation. And then you end up with this. So if I look at this figure and this figure, what they want to know is this a rigid motion? So just a reminder, a rigid motion is anything that maintains side lengths and angle measures. So basically you have two congruent figures. Now, this actually is not a rigid motion because this side length, if I were to actually measure it with a ruler, and this side length, if I were to measure it with a ruler, they are not the same length. These figures are not congruent. And the reason why you know that they're not congruent is that the image is smaller. So if you had to do any type of explanation, that's what you could do. So a couple of others to take a look at down here. If we look at these two, we start here, we have this figure, and then we have this figure. So no, they don't look very similar, but if you were to take this figure and turn it, this corner and this corner would match up. That looks about the same length. My figures look congruent. It's just flip-flopped around, which is okay because transformations can be either flipped or turned. That's totally fine. So yes, this is a rigid motion. I could say figures are congruent. They look like they are the same length, just turned. And then here, this example, we have this this pentagon and this pentagon. This one definitely looks smaller. So no, this is not a rigid motion. The image is bigger. We could even just put. So that's what a rigid motion is. It's just it's any transformation that actually keeps figures looking congruent to each other. So the main rigid motion, main transformation we are going to chat about today are reflections. So reflections are when you flip a figure over a line. That's my little technical term there. So because we are completely virtual right now, we are not actually going to be flipping over lines. We are going to be taking a look at reflections as like in terms of their coordinates on a coordinate plane. So like this is an example of a reflection right here. We start out with this triangle ABC, and then we reflect it over this line, and it becomes it like pops up over here. So reflections, they are congruent figures. They've just been flipped. So the way that you're going to see reflections kind of given to you, or how they may write them, is with an R for reflection, and then they'll say like y-axis. And then they'll put like A, B, C, for example. So this means a reflection over the y-axis of ABC. So this is one way that you could see it written to you for you, but they also could just say, reflect this triangle over the X or Y axis. And we are only going to be reflecting over the X and Y axis at this time. So should be good to go there. So how do we reflect, or how are we reflecting in geometry when we're full virtual? So we're going to talk about kind of the shortcuts, because I call these the shortcuts because in class, this would be a second day thing, but because we are only doing coordinates for reflections this year, I'm going to give you the shortcuts up front. So there are two different reflections that you are going to do. There's going to be a reflection over the x-axis, and then there's going to be a reflection over the y-axis. Main thing is you need to pay attention to whether it's over the x-axis or the y-axis. So that'll kind of be the hardest part for you. So when you are reflecting, you're going to reflect each coordinate separately. So you're going to take a look at each x, y coordinate. And I'm going to walk through a couple of examples to help you to kind of see what this looks like. But if you take an xy coordinate and reflect it over the x-axis, that coordinate becomes x and then the opposite of y. So the coordinate stays in the same order, x, y, but when you reflect over the x-axis, the y value changes. So that's what that negative means, change the sign. When you reflect over the y-axis, all that changes is the x. So that negative, what that means is change the sign. So if it's negative, make it positive. If it's positive, make it negative. That's what that means. So if we take a look, I've got a couple of examples up here. And thinking about our shortcuts, we have triangle ABC, and it has vertices with these coordinates, -5, 6, 1, -2, and -3, -4. And we want to reflect it over the x-axis. So we start out with -5, 6, 1, -2, and -3, -4. And we want to first reflect over the x-axis. So my shortcut down here says to take the point and change just the y value. So -5, 6. So when you reflect, you no longer have A, you have what's called A prime. Now remember, the only thing that changes is the y value when you reflect over the x-axis. So when I write my new coordinate, x value stays the same, y value changes signs. That's it. So then B prime, x value stays the same, y value changes signs. And then my C prime, x value stays the same, y value changes signs. And these would be my new coordinates. Your answers today are going to be coordinates. You need to have parentheses. You need to have a comma. Don't put any spaces in between, but that's what you need to be looking for. So let's take the original points here and do part B. So we're going to take -5, 6, 1, -2, and -3, -4, and we're going to reflect it over the y-axis. So just as a reminder, When we reflect over the y-axis, we change the sign of the x value. If I were you, the main thing I would write down just to make sure I have for today are these little shortcuts. So pause the video, hurry up, write those down somewhere. I would make sure I have those shortcuts. So again, we're about to reflect over the y-axis. So the y value stays whatever it is. The x value changes signs. So the x value, in this case, we're going to have a prime. It's -5, change the sign to 5, 6. It's the only thing that changes is that x value. B prime, change the sign of the x value, leave it as a -2. And then C prime, change the sign of the x value, leave the sign of the y. So even today on your assignment, you're going to see that they're going to give you graphs. Like for instance, your worksheet today is going to have some graphs on them. You are not graphing. Your answers are just going to be the coordinates. So I only want you to tell me your coordinates. So that's reflections. If you have any questions, comments, concerns, don't hesitate to reach out. And again, don't forget that we're always available during our Google Meet times.